Hey, what's up, everybody? Let me pause the video. Perfect timing right there. Get that video paused. We got so much great stuff coming up. We're talking about some MuBot in chat. If you didn't know, the point of command is new right there. Great fun right there. Good stuff. I don't know if you have ideas for MuBot, let me know. But one of the big things I want to point out, we got a big announcement about to come out. Let me drop this announcement here in a second. Let's go check it out. Lots of good news, lots of bonus opportunities. But here we go. Let's jump into it. And great to see you here, Emily, Wilton, Walker, Max, everybody. Great to see you. Daniel, great to see you. Fantasy League is getting crazy. Daniel knows what I'm talking about. Somehow Brian came back in the Fantasy League. He's got playoff chances. Who knows what's going to happen in our BAS Fantasy League. My family Fantasy League, I'm doing pretty good. Maybe we'll look at that here next. You can tell me about your Fantasy League too. But here is an announcement I'm about to send out. So we got assignments coming up. Has anyone watched the activity review from yesterday? I go through and do the full activity, explain through the code, run into a problem with the associate function. Because, you know, what is coding if it doesn't work once? Then you're not coding if it doesn't work. So we have right here, the activity and the assignment are both due. So make sure to do the activity, assignment due tomorrow night. So I know break's about to happen. Guess what? Tomorrow night's assignment is what? Tomorrow night's assignment is what? Who knows what tomorrow night's assignment is? Great job there, Nathan. So tomorrow night's assignment is what? Great job, Lindsay. Good to see you here. Let's throw out some more points. If you didn't here for the 1,000, show up early. My playoff chances are 10% in the BS. I'm probably doomed, but there is a chance. You never know. It changes so quickly. So tomorrow night is the last assignment. Now, there is an activity 11 because we need to make sure we know the material. Tomorrow night is the last assignment, the last one. So last assignment. Let's put here last assignment in red. So it's the last assignment. Doesn't mean you're the last homework. Let's say last homework assignment. Last homework. I don't want someone to be like, this is the last assignment you said. I'm like, but wait, it's last homework. Put that here in a nice calming blue. Last homework assignment. Then we have an activity coming up, so I'll do another activity review. I want to say this. People have been doing great with these activity reviews. I think they've been a huge help because they get a lot of views, which is good. I don't monetize them, so the views don't matter. What matters about the views, I mean, they do matter. What matters about the views is that people are using it. That's what matters. It matters that people are watching it, reviewing the code. Does anyone use the activities? I think I've asked this to help them do the assignments because you see me do thank you, Lindsay, right there. I'm glad they help. And that's what we want. We want you to see examples of writing the code. And so you get this whole video where I talk through what every code means. And I try to just explain it and say, like, this is the check regression. This is what's going on. This is what this code runs. And so the activity reviews seem to have been a lot of help. And always swing by the office hours, which they're ending these days. But we've had some people swing by recently and use them. So thank you, Kevin and Lindsay, right there. We got Review Quiz 2, December 9th. This should have infinite attempts. I think I'm going to head over to the assignments. Should have infinite attempts right here on the Review Quiz 2. Let's go to Review Quiz 2. Let's look at one of those questions, maybe. Save it now. It does. What do we not save? Oops. Need maybe look at this. I think I changed some of the points. Did not say. You make changes, and then it's like, oh, do you want to save those changes? Yes, I want to save those changes. Might need to curve the grades. I thought I updated the points, but we'll look into that. There's always something to look into. I tried to update it to be 100 points, but we'll fix that. So we got questions about linear regression. What should we do? Which number should we do right here? Who's got a question number? Pick a question number. There are a bunch of questions. Did you see one? Yell it out. Be like, question this. This is what the final's going to look like, so know how to do these. This doesn't mean you'll ace the final, but if you take these questions and you're like, I got no clue on any of these. I don't remember covering any of this here, Brian. What are you talking about? Assumptions, checking QQ plots right there. What are you talking about? Log transformation. What is all this? Question 8 right here. Which regression equation does not violate model hierarchy? Oh, we can ace that one. A short answer one? Oh, so short answers are going to be what? They're going to be interpretations of coefficients. I don't think we have any short answers here because that way we don't have to do any like after the fact grading. But short answers are going to be, and Lindsay, great question right there. The short answer ones are going to be very similar to the midterm. If your midterms, you got the full points on. I'd say grades are pretty similar. Your midterm grade is pretty similar to your final grade. Great predictive analytics right there to say what you make on the midterm predicts pretty well what you're going to make on the final. Doesn't mean you're locked into it, but if you were able to do the interpretations on the midterms, you can probably do the interpretations on the final. Probably. There's more dynamic nature to the interpretations, and we'll be covering that next class with the review for class. But you see some things we'll be talking about today right here. So should we do the last one right here? What should we do? Which number should we do? Someone's got to pick a number. I will do 2 of these questions right here. You know what? I'll do 3. First 3 ones you tell me to do, I will do. And we'll see how we do. We should get 3 out of 17 or so. First 3 you pick. Number 15 on the dock. We'll talk about number 15. Pick another one. 8. I'll take 8. I'll take 8 from Nathan. So Nathan picks 8. So we got 15, 8, and what else? We'll talk through 15, 8. And Nathan will get, and then the last one Wilton says. Wilton says the last one. So we're going to talk through these right here. 15, 8, and 17. I might need to adjust the points. 15, 8, and 17 are the choices of the day. And maybe next class show up and I'll maybe do a few more. Okay, let's talk through these and talk about question 15 to start. Question 15 says the logistic model produces, so let's leave the screen for a moment. The logistic model produces the following confusion matrix. Compute the misclassification. So when we do the misclassification right here, we're talking about the what diagonal. Think of a 3-letter word. It means where we miss. The misclassification, what does it want? Compute the misclassification rate. Now, rate should be to decimal format. When we talk about the misclassifications, we're talking about the what diagonal. So the misclassification 3-letter word means we're not on it. It's the what diagonal. So this is called the on diagonal, where things line up with yes, yes, no, no. The other one, not quite, Nathan. I'm going to do a little more calculations. So I think no, this is the first number. The off diagonal. Great job right there, Walker. Great job. The off diagonal. This is called the off diagonal right here. This is where things are misclassified. Does that make sense? So Kevin, great work right there. Kevin's showing the mathematics. I too am like, okay, what's the total? And I think Wilton just solved it. Great job, Wilton, right there. So these are how many we get wrong, and then Wilton went and found out the total is 407, I believe. So that is the total observations. So we're just going to double check Wilton's math right here so we don't get any errors. I don't want to, someone's like, Brian can't even solve it. I don't know. I use code to solve it. So it's 407. That is correct. 27 plus 47 divided by 407. This gets wrong. 18.818181818, so 0.182. And great job right there. Nathan also solving it. 0.182. Does that make sense on how to get the misclassification rate? Can anyone quickly estimate the accuracy of this model is what? Quickly, and by mean quickly, I mean solve now. So can anyone tell me the accuracy of this model? And just use that right there. It's about this. Like, use that. Close. Am I doing it incorrectly? You're doing... Oh, wait, is it... Did I misdo the decimals on this? Should it not be? Change the last... Yeah, there you go. Matthew got it. It's just 1 minus, so 81.8, and it's repeating. It's just the complement. Either it gets it right or it gets it wrong. And just think about what we're doing right here. We're saying this on diagonal right here, we'll show it again visually. This on diagonal represents 81% of the observations. Oh, oof, right there. I'll take it. Kevin, good practice. We're just here to practice. And then if you see it, you're like, do the mental math and then, double check it in the calculator. Because even I was thinking as I was doing the mental math, I'm like, am I doing the mental math wrong? Always do mental math. And then if the two don't converge to the right answer, that's a good way to tell if you're wrong. So take a guess in your head and then recheck your mathematics. Great job, everybody. Good practice. Let's go here to number 8, because 8 is great. What does 8 say? Did you pick a hard one? Ooh, what's it got right here? Okay, so this is using a multiple regression model with a what right here. What is this thing going on? What's the deal with that thing? So we're predicting somebody's salary from their education, their experience, and what the heck is this? What the heck is that thing? What's going on with that? That's a what right there. So what do we got in there? That's a what for that model. Let me scroll down so I can see what people are typing. What is that thing over there? That's an interaction. Mon, 100 points in the chat. You're right. That's an interaction between someone's education and their experience. So we have someone has 3 years of education, and so that's 3 education, and their experience is 17. And experience is 17. That's a minus. And their education is 3. Okay. So now we just go through and we solve through mathematically. Here we'll kind of show it. Please check my math. I'm going to try to do a lot of this in my head. Always check on the calculator. Plus 450. I'm just solving each one of these by multiplying these out right here. 40 times that. So that's... So 840, that's 400 minus 3, that's 680, right? Seems like it should be higher than 680. No, it is 680, I think. Is that plus 680? Double check that one for me. I can solve in the calculator too, but that's 15 times 17. So that'd be 300 minus 45. So that'd be 255. Is that double check all this mathematics? I mean, I can punch it in the calculator now too. Why not? 5 times 3 times 17, 255. 40 times 17, 680. Good. And then 3 times, I think. Okay, we gotta double check though. I think we're good on that. Plus 2880. Make sure to not make a typo. This is where errors happen. If I was taking a test, I'd probably retype it. If I'm doing this as a test, I'm probably going to type this in again and double check, because just math errors happen. That's why I like coding a lot better than solving via this. But does that make sense how we found that? Plug in the numbers, solve. This is the interaction term. But is everyone following how to solve this right here with plugging in the numbers we get? Kind of, wow, look at that. Almost, yeah. Actually reappears like on it. That's cool. It's cool when we hit the undo button, because then it goes boop. There you go. So plug in the... Added that thing for me, right? Yeah. I think I've had students email me like, put a comma in. I'm like, it'll be fine. And then I'm looking at it, I'm like, it'll be fine, right? So I think we get how to get that one right there. We're good on that. And then last but not least, we got number... Oh, wait, that was number 9. Oh, we just got a free bonus one. Well, too bad. Bonus one, because Peel said 8 and I accidentally did 9. Which model does not violate model hierarchy? So what do I notice right here? Which of these does not violate model hierarchy? Experience is being raised to the what in this first model? Let's look at the first model right here. Experience is being raised to the what? Experience is being raised to the what? So does this violate... Experience is being raised to the what right here? Let's talk about the model hierarchy of this and see if it meets model hierarchy. Talk to me about experience is being raised to the what power? The highest order polynomial on experience is what right now? The second power. So that means to meet model hierarchy, I would need what? So to meet model hierarchy, I would need what? Correct. Experience is second power right here. Correct. Exactly. Great job. And then to meet model hierarchy, I'd have to have what right now? Because experience is to the second power. So we'll draw it out. I'm sure someone's wondering, what are we talking about with model hierarchy? So if we're talking about experiences to the second power, every power that's lower, right? So if we have something like this x variable experiences to the second power, then we have to have to the first power. So we see, once again, that we have to the second power right here of the x variable. That's just the name of the x, it's experience. So do you see experience to the first power? Yes or no? Do we have experience to the first power here? Yes or no? Do we? Do we have experience to the first power? Your thoughts? Yes or no? Put a little chill music on. Nathan's 100% right. That's what that is right there. So what does that mean? That's the answer. This is the one that meets model hierarchy. The other ones do not meet model hierarchy. Let's go take a look at those real quick. Just review them. This one right here has education to the second power. And then we see, we don't see an education. Wait a minute. Oh, it does meet it right here. Okay, so it does meet it. I got a little scared there. It does have education right here, but explain why this does not meet model hierarchy. And it actually goes to this idea. For this one, we have the x1, x2 interaction. I'm blocking that a little bit. We have the x1, x2 interaction. So it has a second thing where it needs to have model hierarchy. Why does this model not meet model hierarchy? 100 points right there. Why does this model not meet model hierarchy right here? Because it doesn't have what in it? Why does this model not meet no experience? It doesn't have experience. It has, it's missing this single term in it. And so it's missing, like, if you draw it out, it would look like it's missing this component. Missing the x2 of the x1, x2 interaction. The other ones are the same thing down here, where this one is missing a component. You can see right here that we have education, but we're missing the experience by itself. And then this one right here has experience to the second power. So we'll highlight that in yellow. And we don't see experience to the, we don't see an experience to the first. Exactly. So does this make sense here? Why certain ones violate model hierarchy? This is a really good question. It's complicated if you look at it and you don't know what model hierarchy is, especially with this one. That one's a tricky one right there. It almost caught me off guard. I was like, well, wait a minute. It has education to the second power, but it has an interaction. It doesn't have the term for the interaction. So I don't know if I wrote that one. Maybe I wrote it a while ago, but that's a great question. And then last but not least, we have question number 17. Let's go here. The last one. This is a Wilton's question. So the last one says here, which of these is most computation heavy? So do you think it's in all the models or just a forward search? So all possible models searches through all possible models. Forward search searches forward through a list of models. Or we'll talk more about how it does it today. Which of those sounds more computation heavy? Kind of in the name of it. So when a variable is to the second, that means that we have to include the variable itself. Yeah, exactly. So that would be to the first power. Exactly. Max 100% right there. Exactly. So yeah, it's taking a variable squared transformation. Yeah, so it is a transformed. It is a polynomial, the variable. So including like a transform to the variable to the second degree would be like using the polynomial relationship of that variable. So to preserve model hierarchy, which is not required, you would have to do the lower order terms. Correct. You'd have to do the first power, which is the variable itself. Because if you don't put an exponent on it, it's to the first power. Like, what's something to the first power? It's the variable itself. Great. No, great, Max. Great clarification right there. So we should get, what, a 4, like just 20 points? 13 unanswered questions. That's fine. That's fine. Oh, your quiz score has been muted. I trust it. I can't even see my quiz score. I'll probably unmute these scores. Says it's out of 100 now? We'll unmute those a little bit here. We should be all right. Those are the answers. Done it a bunch. Head back into the main screen. Let's go talk more about what else is due. So we got the review quiz. We got the take-home final is open. Who has taken a look at the take-home final? Who has gone in? Let's go to the assignments. Who started up the take-home final? And thank you. I think was it Daniel or someone mentioned there was an error with the name of the file. Who has started the take-home file? Yeah, let me unmute that now. Why is it muted? Let me unmute. I'm going to do a little... Let me go look at that. Let's go. I think I used to have like posted muted or something. I'm like, where do I go to unmute it? Here it is. Let students see. You're supposed to see the correct answers. Okay, too soon. Bring us over here to the other screen. It doesn't show any muting options. And we're going to talk about the take-home next game. I'm doing grade stuff for a second. Let me go to the... I'm going to unmute. Put it to auto post. Search assignments. No, wait. Review. Okay, 1 second. Wait, it should... Wait. I want to do the posting options. Oh, Canvas, I don't like you sometimes. It says no grades to post. I might need someone to take it. It should... Your quiz is muted. Oh, it's saying there's things to grade on it? Wait a minute. Did we seriously put, I don't recall putting something to numeric response on here. 2 seconds here, everybody. Because that takes a lot more time to grade. I will probably take a look at this afterwards, but you have unlimited attempts and it's supposed to be instantaneous grading. And I don't know why. I probably need to fix this up pretty soon so that way it doesn't cause anything. It shouldn't be saying, they're all like multiple choice and they're all numeric responses. Yeah. Tell me what it says. I don't know why. I'll look into it. It's not supposed to. I don't see any written responses on there. I'll figure out what's going on with that. So sorry about that right there. We'll get that fixed up. So with this right here, here's the take-home final. And when you do this, this is probably so key. Make sure you do this. You are downloading this right here, and then you are opening in this inside of RStudio. This should not open inside of R. I'm going to open it inside of RStudio. I'm loading this here. You probably don't have it set up to load the way I do. So what you want to do is you want to click over here. No, we have a next class next week. You want to click over here to the load workspace. I want to see people writing this in the chat. I will throw the 500 points if everyone starts typing in the chat, load workspace. Does everyone see right here the load workspace? What you will do, someone's going to email me. Don't worry. Please email me if you're stuck. But you will go here to load workspace. And because a lot of people's R is not set up the way mine is to load instantaneous by clicking a file, you'll probably go to R because it's default set to R. So you're going to go to load workspace. I need more load workspace in the chat right here. Load workspace. We're going to give out those points in a second. And when you click load workspace, I'm doing it here in the background. It'll open the files on your computer. Then you're going to click the take-home final. And guess what it does? Bada bing, bada boom. It loads the workspace. Let's give out those 500 points right here. People know to load that workspace. 500 points in the chat. Make sure you know to load the workspace. Big thing. Big boom right there. And so that is what we're doing. We got our workspace loaded in and we're good to go. Got our time series in the corner. Beautiful time series. And so let's clear that off. Clear out everything. Get everything nice and neat right here. And then when you make your final, you're going to go to final for fall 21. You're going to type in your ID, which my ID is 2. I'm student number 2. I don't know who student 1 is. And there you go. So now you need to open up this file that was created on your computer right here. So go ahead and search your computer again and go to the file on your computer and find that file and go to it. Does this make sense? Student number 1 is Ben. Wake up, Ben. Actually, kill me, man. I love it. Student number 1 is Ben. Ben's always been here. So here is your student ID right here. Due date. Jesus, 2020. Let me change that. I need to change that pretty quickly so no one gets confused. But yeah, going in here, I made some updates to everything, and we have, make sure at the end, I do want to point this out. When you're running this here at the end, make sure to run a set seed. I think people notice this, but when you are making your models, you will see that the check regression actually, I think, who pointed this out? Someone was pointing this out. I think Nathaniel and Charlie on the Discord was talking about how the check regression uses different numbers or uses randomness. So make sure when you're doing your check regression to run a set seed on it, or you might not get the right answer. So run the set seed, follow the directions very carefully, could run into a wrong answer. So that's the take home. I'm just gonna make a few more quick updates to it. Oh, so many updates. It's almost break. Oh my gosh. The instructions are right here, and I will put the link to submit shortly up, so you'll see that soon. Please do not communicate to anybody about it. Like, you can be like, man, take home's pretty tough, but don't start asking people how to do things. If you have questions, ask the instructors. If you feel like maybe you shouldn't be asking something, especially on the Discord, like, hey, how do my code's not running here with the, I'm predicting whether someone's a smoker. What do you think? What error do you think? Are you allowed to explain us how to run a set seed? Yeah, so it'll, yeah, I can explain that. No, that's a great question. Just before, so I'll write part of this code right here. You'd go set.seed 320 and then check regression. Frankly, I might have just ran all the code for you right here. That's kind of the answer to this question. If you have your model and then you know what to look at in the code, I think we just solved it. How are you feeling about the take home when you see that right there? So run set seed, which is the code right there. And then, and probably if you want to be really careful, do that. What is this doing? What did Brian do for 100 points right here by putting the code like that, which is going to be really careful. It's going to say can't find model M. I don't have model M stored. Number 8, I'll look at that here in a second, Nathan. I'll look at that here in a second. Good question. So what do you notice about that code right here? And I'll kind of explain some stuff. I can explain. Can't really tell. Exactly. That's what I'm doing. So that appends code. It puts 2 lines. If you do a semicolon, lines get joined so they run together. It just says run this line, run this line. So it's not really an argument. It just joins lines of code. So rather than having it on 2 lines and hitting run, you can just go here and put it on 1 line of code. And so if you want the set seed to run for certain, which is kind of a safer way to do it, you can have the set seed and then the code after it. What does set seed do? It makes the randomness the same. It sets the randomness. It's like a seed in Minecraft, so you get the same world every time you create it. So this will run the same random results every time. It's still random, but you will still get the random results. Build a logistic model predicting buy from all predictors with no interactions. Report its misclassification rate. Ooh. Here's what I would say. Well, one, so I can't explain too much, but does anyone remember us working something earlier where we were doing something very similar to this? So if you watch the earlier part of this video, I think we've got some good help. You just have to know how to build the logistic model. There's some important things we need to make sure we do, like, some GLM and I don't know. You know what I'm talking about? Go watch the earlier videos. But there's some important stuff we need to do. We need to know how to put in all the variables. So when you hear all the variables, I'll let you type this in the chat. I'm thinking 2 things a little... Who's thinking when you hear all the variables, like, you should be thinking something. I'll let you put that in the chat here. But when you hear all the variables, yeah, Kevin knows right there. That's what all the variables means. Great job, Kevin, right there, 100 points. So when you hear predict this variable from all the other variables, you're doing a logistic model that should tell you certain things. And then if you go back to the earlier part of the video, we did talk about how to get some misclassification rates. So who feels good about this question right here? Level 1 to 10, how difficult does this question seem right here? Like 1 being like, that's a joke, or 10 being like, that's impossible. No one could solve that. How do you feel about this right here? And what I think 4, I like that 4 right there. If you had heard, I like 2. If you had, I got this, when we build a model. If you had heard you'd be doing, I don't know. I hope you think it's pretty cool, because I think it's pretty cool that if I said, make me a logistic model from all the X variables, predicting the variable by, and tell me the misclassification rate. If you had heard this, that you'd be doing this at the start of the semester and writing this in code, what would your thoughts have been? Would you have been like, there's no way, I don't know. I think it's pretty cool that you can get to this point. Also, watch this week's activity. I do a ton of this. But there's a lot of potential. I would have dropped the class. You're like, I would have dropped the class. No one can do that. No one can do that. You got this. I'd be like, bro, you got to be kidding me, man. Do you even lift? What's going on here? So we can work on it a little bit, but at a time, right? Yes. I would save the environment too. Yeah, always save the environment. Go up here if you're working on it and probably save what you have and call it's your workspace, your environment. That's where the 100 points. Call great advice right there. Save your environment, keep track of what you're doing, and then save your workspace so you could just load it back in. And then this becomes your workspace. Save the RMD file. Just make sure to save your work and keep working on it. You can always regenerate it if you lose it. You just might overwrite stuff. So probably best to just save what you're doing. It's not too bad. 2-3 hours. Not too bad, I'd say. Like, it depends. I could probably work through this in 10-15 minutes, but that's because I teach the class. What we have is usually a rule of like 5 or 6, that how long it takes us, we expect it to take students 5 to 6 times longer. Charlie Quick told me that rule. He's like, Charlie Quick always takes his own tests and then multiplies it by 5. So if he has like an hour and 15 to give his class to take a test, then he should take it in about 15 to 20 minutes. Because he knows every topic, so he's just, working through it. The last submitted document is 1 graded, right? I think so. That sounds accurate. A little bit confused on that. If you can expand on that, Walker, I'll answer more. We will. Sorry, I don't have it posted right now, Kevin. I'll get that posted. I just noticed that it's not posted either. Sorry, I was trying to make some changes to stuff and get things updated for this semester, and then I'm already seeing errors. Switch it to highest attempt. Oh, okay. Is that for the... Are you saying, Nathan, for the for the yeah, thank you everybody. I tell you the craziest thing, I promise I'll stop talking about one of these days, was just like, you know, mid-semester, like having surgery. Man, it's just like you don't expect stuff like that. You're like the day before I was like, everything's great. And then I was like, holy mackerel. Like, let's go get surgery. It's fun. Let's just go get surgery. I'm fine. Don't worry, I'm fine. Where it should be highest attempt. Yeah. Keep the score the highest. Allow multiple attempts, score is highest. Which one? People are saying switch it to highest attempt. Nathan, which one are you talking about? Switch to highest attempt. The quiz is the highest attempt. The like if we submit it and go back and make changes. Oh, to the Google Doc. I use its latest attempt. Yeah, you don't get multiple attempts. No, sorry, I was misreading what people were saying. My brain's just working away right there. No, the Google Doc is your most recent attempt. I should probably just delete off the other attempts. That's why I might do this semester. It makes it easier when I have to like make the grading keys. So you don't get multiple attempts at the Google Doc. You get one attempt, your latest attempt, and whatever that latest attempt is your final answers. It's like you're submitting the project. Generally, it's not the end of the world if you resubmit, but you generally want to submit once. I mean, like, if you have to resubmit, but don't like, I mean, you could, I'd only count your latest submission. You could submit like 50 times, but then that just creates more things that I have to run and go through. But I'll probably just remove off the submissions that are not someone's latest submissions, which is probably just a smart move since I only use the latest. Good stuff right there. We got the Proctorio opening up. So really great stuff right here. The Proctorio is open during our period when we take the exam, but it's also open the whole period for everybody. So I hope everyone likes the schedule right here. We're allowed to have it open longer, which I think is great. So this allows for some flexibility right here. Please tell us if for some reason you have a major conflict. If you're like, Brian, I'm leaving the country. I got to go to somewhere where they don't have internet. And, you know, military's calling me or something, then we'll work something out. I think this should provide enough flexibility, and it's through our scheduled exam period that people should find the period of time to take it that works for them. Everyone good on the Proctorio exam period right here? Looking good. Good stuff. I think we're good. And last but not least, your reviews of the class really do matter. And so with that in mind, who wants to get points on the final? You still get a page of notes. Yep. Still get that page of notes, which I would use for interpretations. A couple, extra days for it. So right now, right here, right now, let's go ahead and take this link. This link should work in the chat. Go to I'm probably going to have nothing on it. It's going to show me I have no evaluations. I can't take any. So hop in right now and start the evaluations. I just want to say, like, I read through these. It's not just myself. It's my department head reads through these. I read through these. Charlie Quick reads through these. Steve Mangum reads through these. Dean Mangum. We read through these a whole bunch. And so we need to get our percentages way up. We're pretty low right now. Mun, thank you so much, Mun. I appreciate that. But hey, it's worth those extra credit points. And usually 320 is pretty good at response rate. 87%. Love that right here. But yeah, going in, you can go and see any of my semesters. I'm pretty sure I can show these. They're anonymous. So you can see usually we get like 94%. It's pretty good right there. So if you can take a moment, if you've already done it for me, do it for another teacher. They'll be so happy. And if you see 201 where I don't give extra credit, maybe I'll talk to Terry this year and say, can we give extra credit? Because look at that, 92% of 71 students. How did I have 71 students in one section? I don't know. I'm trying to remember this semester. What semester was this? Fall 2018. It is for our section alone. So we can do this. Do you think we can do this? Do you think we can get... I believe it. I believe in us. Do you think we can get this 90% and get 3 points on the final? 40% is actually not that bad, but you know what's better than 40%? This 92%. And I promise you, I view all these results. I know where I take my hits usually. Like usually the instructor contributed. Yes. Ooh, wow. This is one of my lower reviews. Oh man. I hope it's not that low this year. 4.69 is kind of low for me. Oof. We've got a fall 2020. That's usually 4.69 was where the instructor. 4.95. Woo! You never know how it's going to turn out, and I appreciate your responses. And I read through, especially the qualitative. I read through this, like a lot of nice things people have to say. But then you will see, you know, comments that are critical, which is good. I want critical comments. I want people to tell me what's going on. But you know, tell me what's going on. Tell me what you think. I like the YouTube better than Zoom. Thank you so much. Yeah. So anyways, I read through all your comments, every single one. So, so no, I appreciate it. So you're seeing what other students have said in the past. It's anonymous, so we're good on that. The assignment-based layout of the class has been very helpful to grasp. Yeah, cool. Please be critical if you want to be critical. What's really crazy is every once in a while, I've had it where you can tell someone really didn't like the class, and you'll see like the one on the disagree on everything. Like you're like, oh, or maybe they just clicked the wrong side of it, but like, oh, that person was not happy with me. Can't please everyone. So anyways, I want to point once again why this is so important. It's so important because in the Haslam College of Business, once again, I read this. Terry Higgins actually gets access to my 201 ones because he's the coordinator of 201. So Terry Higgins sees my 201. So if you were a 201 student, Terry Higgins might read what you write about me for 201. Charlie Quick reads these. He's the director of undergraduate. Mike Galbraith reads these. He's our department head. There's 4 people for 201. Terry Higgins is not involved with 320. We don't really have a coordinator. We all kind of work together. But 4 people for 201. And then Dean Mangum. And then there's maybe other people who read at the university too. There is a handful of people who probably could read what you write. I will definitely read what you write. I will read what you write. If you have nice things to say, if you have advice, if you have critiques, and you can always tell me things you want publicly too, but anything you want to say, good stuff. One of my most critical classes ever, I don't even know if it's still far enough back that I can see it, is 207 from years ago. Is it so far back I can't see it? This could be it. Is this my most critical class ever? Yeah, it is. I learned a lot from this review. Remember I was talking about those 4s that I like? I learned a lot from this class right here. I'd say this was the first time I ever felt like I didn't meet my expectations, and I could tell it during the semester, and I learned a lot. And so this was my first time teaching 207, and you can look at the reviews, and it kind of shows it. And that class right there, you can see I was in the 3s and the 2s, which that's just like, yeah. But then you come back, you say, okay, you know what? I'm going to learn from this. I'm going to read all those reviews. And where's my next 207? Here's my next 207. So I looked at all those reviews. I read all those reviews. And here's my next time teaching 207. So looked at all those reviews. So this time you see there's really not the strongly disagrees. And people are much on track, or the answers are very different. I don't give feedback to assignments. I don't do feedback. Yeah. So anyways, please give your responses. I read these. Almost every student responded, which is awesome for this class. And the class that even gave me reviews saying that were critical helped me become a better teacher for 207. I'm always looking to improve. So anyways, that's what we got going on. Let's get ready to do more material. So the biggest thing is, one, we've still got a little bit of work to do. And please email if you're stuck. We've got the Discord. A lot of people, who's been using the Discord to get help? Because a lot of people got their max bonus. Let's go over here to the 320. Yep. I was talking to Nathan. Nathan and Kevin were asked some great questions yesterday about the assignments. So Nathan and Kevin already got the heads up on the activities and assignments. So yep, Kevin's like, I know. I already know that there's no more assignments. I already know there's only one more activity. And did we send out that announcement to the class? I did send it out, right? Nope, didn't send it. Let's send it. And so we're sending it out right now. So if you're on the Discord, you get information first, and you get to know what's going on. We do send it out to everybody, obviously, but really easy. Just ask a question. Just tag me. Best thing to do is tag me, and then you will see me answering questions. And I really appreciate it. Let's go right here and finish off our last bit of material. Who can remember the name of the Japanese statistician who came up with a really cool way to tell how close our model is to the truth? For 100 points in the chat. Who knows the name of the Japanese statistician? What is his name? I'm going to say it properly this time. Dr. Bosdogan told me how to say it a while back, and then I forget. Thank you so much, Nathan. I appreciate it. I try to hop on there. Level 5 is the max. Probably Kevin's already got there. Today we are resuming our talk. Going over to this part of the notes. AIC is correct. That's what he came up with. It's his information criterion. So it's the information criteria from Dr. Ake Ike. I remember Dr. Bosdogan told me how to say it, or Bosdogan, so I got to practice everyone's names. Ake Ike. But really great Japanese statistician. And so basically it's trying to minimize what? Like, just in short, it's trying to minimize the what? Which is our whole goal of these models anyways. There is a beep. Ake Ike. So it's trying to minimize the what right here. What is it trying to minimize? Which we try to reduce this all the time. What is it trying to reduce? This model right here is trying to reduce the what? What's it trying to reduce? Is it trying to reduce the sample size? Is it trying to reduce the number of variables? Is that what it's trying to reduce? Is that our goal in regression, is take the smallest sample, take the smallest variable numbers? What is it trying to reduce? Which goes back to the whole idea of regression. Minimize the sums of the squared error, reduction in sums of squared error. That's exactly it. The sums of the squared error, which is the literal error, which is a residual, and then we square it, and then we take the sum of it. So we get a sum of the squared residuals, which is a quantity of how much error we have. So when we get this quantity of error, we want it to be as close to 0 as possible, and that will make this information criteria water and water and water and water and water if we get the sums of the squared error to be close to 0. The information criteria gets this or in this or in this or. It actually goes negative. Remember, it can go as far as negative infinity. It'll keep getting water, which is better. This is what we want the information criteria to be. It's odd to think this, but you want the information criteria to be water. You want your information criteria to be water and water and water. Like the more this it is, the better. You want it to be smaller. Yes, you want the smallest information criteria possible. So what do you notice here that predictors do to it? They're whatting to it. Just tell me about this symbol right here. Just 3-letter words. Adding X's to the model, which is what the K stands for. They're the predictors in the model. So adding X's to the model would increase model complexity, which is going to add to the information criteria. And if we're increasing the information criteria, then it's penalized. Wilton, perfect answer. Like, beat me to the words. It's penalty term. And that's what you see over here with the AICC, which is the Ake corrected information criteria. And he does this to add an additional penalty term, which is, once again, if you notice this, if you think mathematically, as n goes towards infinity, what will so think of a limit. As n goes to infinity, what will the additional penalty term approach? So as n goes to infinity, just think about where it's at in the equation. As n goes to infinity, exactly, Max. So you're almost using AIC for, like, AICC and AIC converge at larger sample sizes. Does that make sense mathematically? Like, if someone's like, should we use AIC or AICC? And you'd be like, well, you can always use AICC. It'll just converge towards AIC because the second penalty term is partially based on your sample size. And there's a larger penalty for models that have a smaller ratio of sample to predictors. So the ratio of your sample size to the amount of predictors. Exactly. No, I'm sorry, Nathan. Nathan's having some calc flashbacks. So we don't solve these things. We just have to understand how they work. We have to understand that. So with a sample size of, basically, probably after it depends on how many predictors you're using. Because if you had 50 billion predictors max, then they wouldn't be close. Because the predictors are going to subtract from the sample size. Does that make sense? But who has 50 billion predictors? No one. So max, pretty much in all instances. But we can think of Max. You're really making me think right there. Got some great questions right there. 100 points max. Pretty much just large sample size. But then, are you using a lot of predictors too? Because that's the second question. But for large n, the two metrics converge. Rock. It doesn't matter. In most ways, it doesn't matter which one you're using. You could always use AICC because it'll converge to AIC at technically sample size infinity. Now, when are these differences big? There's only two numbers I want you to know. The only two numbers I want you to know are 2 and 10. Everything inside of 2 and 10 is a what? Like a, how would you react if the difference in AICs are between 2 and 10? You'd say, I don't know. So 2 means they're virtually identical. 10 means they're different. So if I told you I have 2 models I'm selecting between, and the models here, model 1 has an AIC of, let's say, negative 15. And model 2 has an AIC of negative 14. Which model did best? Model 1 or model 2? Which model is closer to the truth? That's what AIC stands for, how close our model is to the truth. It's just a metric. It's an estimate of how the closeness of our model to the truth. So how do you know what the truth is? I don't know. Which of these models did best? 1. And the answer there is because 1 is the most negative. So 1 is the most negative, so it's better. Now, what do you think about the differences between AICs of these models? The differences between the AICs of these models are what? Are they like, yeah, these are basically the same, essentially equivalent? Are they essentially equivalent? Are they kind of like in a confusing range? Or are they like, yeah, this model's way better. Model 1 is way better. What do you think? Is it in like they're essentially, it's small. So the difference is only 1. So the difference between these two AICs is a difference of 1. Negative 15, negative 14 has a difference of 1. They're essentially the same. Like, it's like, well, both these models are basically the same. Does that make sense? But if the difference here had been the following, which model is better now, model 1 or model 2? Now, which model is better? Model 1 or model 2? I'm trying to trick you. Which model is better now? Which model is better now and why? I'll explain the why if you just say 1. It's still model 1. It's still the most negative. So I was trying to trick you being like, no, it's still model 1. Model 1 is still better, but now, do we have evidence or do we have good reason to believe that model 1 is a good bit better? Definitely 1, exactly. It's most negative, so definitely 1. The lower the AIC, the better. And now at this point, and I think Wilton's kind of confirming this, it's definitely 1 because the difference is more than 10. It's substantially different. And all we're doing here to see how different it is looking at the AIC differences and saying, well, how far apart are those AICs? They're negative 14 apart or 14 apart. And the difference, Nathan, top tier answers, that's exactly it. And the difference between model 1 and model 2 is a difference of AICs of more than 10, so substantially different. So the only 2 numbers I really care about on this screen are 2 and 10, and 2 means they're virtually identical, 10 means they're very different, and between 2 and 10 is like, I really don't know. It's a gray zone. There's not like at some point it becomes different. At some point it's virtually identical. If it's 2.1, it's probably virtually identical. If it's 9.9, it's probably pretty different. It's just this gray zone of like, when is it different? When is it the same? And I don't care to talk about the gray zone. I'm more like, here's where we think it's the same. Here's where we think it's different. So with this right here, the statistical significance. Oh, yes. Statistical significance doesn't matter in AICC. It doesn't matter. Rock's there for us all the time. So when we figure out the AIC, the model that's best on AIC, we will oftentimes get things that are not statistically significant. And you'll see this a lot of times when we fit all the models right here. So this is what we were just talking about in the practice quiz, is fitting every single model. So to fit every possible model, you would run the equation here to know how many models you are fitting. We'll see the code to fit it here in a second. If you fit all possible interactions, how many models would you be fitting? Let's say we had 8 variables, and this is how to run it. So if we have 8 variables, how many models would you have to make to look at every model with all the two-way interactions? Oh, no interactions, excuse me. With no interactions, how many models would we make? No, that is with with interactions. I was like, wait, that doesn't. Oh no, that is no interactions. Sorry, I'm reversing everything. I'm like, I'm right, wrong. How many models would there be? With no interactions, with 8 x variables. We're saying like we collect height, weight, GPA, 8 x variables. With 8 x variables, how many models would be created? You can show me I think it's 256. I think it's right. 2 to the 8th power. So 2, 4, 8, 16, 32, 64, 128, 256. That's with no two-way interactions. That is the fun equation to solve. So 2 to the 8th times 8 plus 1. What do you think this is going to do right here? So that's going to be 4.5. What do you think this is going to do to the amount of models if you solve this through? Oh, yeah, that game where you double everything, right? What do you think this is going to do to the amount of models if we include two-way interactions? What do you think this is going to do mathematically to the amount of models if we have 8 variables and we include all possible two-way interactions? What do you think that would do? We're probably going to have a what? If we include all two-way interactions, we're probably going to have a lot more what? 2 to the 36 power? Whoo! Craziness. Craziness. A lot more models. Gonna need a bigger boat. So that's gonna be a lot more models right there. Crazy amount of models. Crazy amount of models. So that's, yeah, 2 to the 36 power. Just run that through the Google machine. What is 2 to the 36 power?
2 raised to the 36th power is 68,719,476,736.
Nothing like 68 billion models, right? And that's with 8x variables. This gets out of control rather quickly. We show some of the calculations, I believe, right here. So this is showing the code to do it using we're using the reg subsets. That's the code we're using. We're using reg subsets to do this. And this will do regression subsets right here. If you look at it, we have right here the code showing the best models within 2 AIC. Why are we? Oh, we're showing within 4, actually. Oh, so we only really care within 2, but we're showing within 4 AIC. Are these models virtually identical? Yes or no? Are these models here virtually identical? Yes or no? Quick, easy question on this. Imagine it's a test question. Are these models virtually identical? And here I'll compute the difference. The difference is 2.8. So are those models right there with their difference of 2.8 between their AICs virtually identical? Yes or no? Thoughts on that? Are they virtually identical? Nope, they're not. Great job right there, Matthew. They're not virtually identical because the AIC difference is more than 2. They're kind of in that, like, I don't know, range. They're like, I don't know. They're not virtually identical, but they're not really different. They're in that I don't know range. They're, I don't know, not virtually identical. Good thing to know right there. And so now considering all two interactions, whoo, look at this right here. Now there's a lot more variables right here, and we see totally different AICs. Number of variables right here is 4. All these models right here are virtually identical. So these are like our candidate models. And this model right here looks to be the best. It looks to violate model hierarchy. I see gender over here. It went off the screen. We are violating model hierarchy because a bunch of things are not included from the single order terms. And so what this code does, and here's our final model, which definitely violates model hierarchy. And I think this is not statistically significant. That's all right, though. Doesn't matter. Doesn't matter. Because we're selecting based on the AIC criteria, and just the way in which some variables might be needed in the model might mean they're not significant. It's just the way AIC do. We no longer look at the p-values. We only look for the lowest AIC to figure out via the School of Information, what Akaike started, or kind of built upon and really founded the foundation of it. Just looking at the AIC criteria to select the model. Here we are with trying to predict somebody's body fat, which we've done before using the reg subset command. So how many models are being examined right now? Method exhaustive. How many models are we looking at if we use exhaustive method right here? Thoughts on how many models are being created? And the answer is what we're saving it into. How many different models are we creating? Do tell me. How many models are we creating? The answer is what we're saving it into. We're creating how many different types of models? We can see how many models we're creating. We're creating 8,192 different models, which is pretty crazy. Getting into some data mining here. We're creating 8,192 different models. Like we're using age and neck and height and all these different things. We're creating all of them. Every single possible combination of X's. And then we're looking at them and saying which of the combination of X's are the best. And we have right here, there were 13 X variables, and these 8 work the best. We looked at the one with all 13, and we said, no, that's not the best model. And then how many models are similar to this best model? So that best model, so not how many models are equivalent, but how many models work virtually the same as the best model. So there's the best model. How many models are virtually identical to the best model? Good review questions right here. How many models are virtually, so it's okay if model hierarchy is broken? Yep. Model hierarchy is just a guideline. We don't have to do it. The AIC selection will often violate model hierarchy because it doesn't know or care about that. It's just an algorithm that searches for the best AIC. So it's almost highly likely. They did a great job jumping in there. It's almost highly unlikely that you would ever get model hierarchy if you do very advanced models. So right here, we see these two are similar because their AICs are within 2. If you just add 2 to this, you'd get 7051, and you can see that that's where the difference would be more than 2. So those are the 2 models that are virtually identical. Technically, you could probably pick the 6-variable model and say, let's use the 6-variable model because it's a little simpler. Here we're selecting based on a subset of the variables and doing all possible combinations. Now, the reason you might not do it with all the variables is because you're going to get an insane amount of variables. And there's the AICs, and you can see the drop in AIC. Did doing this approach right here actually help us? Who can maybe talk to me a little bit about these numbers right here and explain why doing the approach maybe helped or did not help? Like, look at that number right there. I think it is. Let me double check. It might not actually be a reg class function. I'll double check here in a moment. And Nathan's pointing it out. And let me double check where the function lives. The reg subsets function is leaps. It's not a regression class function. Model selection by exhaustive search, forward and backwards and stepwise, more on that soon, or sequential replacement. We don't do sequential replacement. But it is from the leaps library, So it's not reg class. It's not a reg class function. And we can do it other ways too. I'm not going to those today, but we could. This is a very common algorithm, so the leaps package has it, but good stuff right there. And so we see right here our final candidate model. We see here things that are not statistically significant. And is model hierarchy broken right here? You can kind of tell by the way the code's written. But is model hierarchy broken? Is model hierarchy broken? What is your thoughts? I'd love this as a test question. Is model hierarchy broken? Here, I'll give you some hints. Look at that, or yeah, you can just look at that. Yeah, this is about as broken as model hierarchy can be. You only have age by itself. Abdomen's missing, wrist missing, weight is missing. You're missing a bunch of the lower order terms. This is as broken as model hierarchy could ever be, which is all right. So now we're using 38 predictors and we're getting 740 billion per billion models. If you had wanted to do all possible models, you would need 10 to the 223rd possible models. Yeah, this can take a while. If you had considered all two-way interactions with your 38 variables, you would have to solve the following equation, to figure out how many models you need to make. I'd maybe write these down for your formula sheet. Doesn't really matter much. Oh.
It doesn't matter!
It's just one of those nice things. It's nice to have model hierarchy, but if you don't, it's like if someone's making a steak for you and you're like, I'd really like some mushrooms, because you gotta have mushrooms with your steak. It's nice to have mushrooms, but you can still have the steak. It's just nice. We like our model hierarchy, but we don't always get it. I want mushrooms. This is the all possible with logistic right here. Can't tell I'm hungry. All possible with logistic is using a slightly different function. So you can see the GLM multi right here doing the all possible, and you can see all the arguments we need to add. And I don't think we have you do this much, but here's the all possible, and it runs way slower. And I do have some more advanced ways of doing this, so I'm not focusing too much on this, but I wouldn't focus too much on this because we don't use this code that much, but it is possible via it. But let's talk about search procedures. What did you notice, which kind of goes back to your quiz, is the problem with all possible regression? What is the problem, especially if you're doing data mining with a lot of X's? What is the problem with all possible regression? Like, where is this going to be like, yeah, I don't know if we can do this. This is going to be problems right here. What do you notice is the problem? What is the problem with all possible regression? Which is not bad, but takes too long, too time consuming. So especially when you get into a lot of X's, you're going to have, it's all wrong. Might be. Never know. Oh, wrong button. Really clicking wrong button. So, there's neural net on the screen. So when you do this, it's all imagine if I told you we're gonna go. Here we go. Here's the United States. There you go. There's the United States. So we're gonna start over here in Knoxville, Tennessee, and then we're gonna drive up to New York City. Gotta go over and then gotta go up. And I want you to find the best pizza place along the way. So here's where you're gonna start, and here's where you're gonna finish. If I tell everyone to drive to New York, do you think everyone's going to take the same route to drive to New York? I don't think so. Everyone's going to take a different route to drive to New York, and they might have a different finishing spot then. But guess what would happen if we did our original way of doing it? What would take a very long time to do if we were trying to say, find the best pizza place from Knoxville to New York? What would take a very long way of searching for the best pizza place? From on all pathways we could take from Knoxville to New York. Kind of make a big grid. What would take a very long, very exhaustive way of doing it? What would be a very long, exhaustive way to find the best pizza place from Knoxville to New York? A very long, exhaustive way of doing it would be to check all possible, right? So when you think about this, like computation-wise, to look at all possible pizza places from Knoxville to New York, and the answer is Hard Knocks Pizza. I mean, because come on, it's best pizza anywhere. So if you were to check, you don't even got to leave Knoxville, see? At least 77 different. You have to try all the Domino's, Max. But what about if we change up the way we're doing this? Instead of trying all possible, we start searching. And we start in this direction and we just keep going forwards towards New York and we just keep searching. But why do we have to drive to New York? What if we, instead of driving to New York, instead of searching forwards, we could also start in New York and do what? So you could, instead of starting in Knoxville, so we go right here up to New York. You could instead search how going from New York. Instead of going forwards towards New York, you could go where? Like instead of going forwards towards New York, you could do what? So we're not going forwards towards New York now. We're going where now? Which way are we going? We're either going forwards towards New York or where towards Knoxville? Because if New York is forwards, Knoxville would be where? Go backwards towards Knoxville. Matthew, you got it right there. Go backwards. So when you think about this and how this applies, let's think about how this applies to what we're doing. What is the simplest possible model for us to start out with? What is the simplest possible model? Like if you were to say, Brian, I want you to start with a very, very simple model. I want you to start with a very simple model. Like the simplest model I can think of is the what? So what would be a simple model to start out with? Very simple. Ridiculously simple. It's like got nothing in it. Nothing at all. Simplest model we can think of has no X's, and that's called the what? I'll give you hints. There's a hint. Another hint on the screen. The naive. Great job, Matthew, right there. The naive. The naive model has nothing in it. So then what could we do? We could go to a model with all the X's. And what we do is we start driving down this road and we start putting in the X's. And if I start putting X's in the model, you would say to me, Brian, you're doing a what selection? So I'm going to start with the naive and I'm going to start adding in X's. So that's not where we drive backwards from New York. We're now going along this path here. That would be called a what selection of variables. So driving towards New York, figuring out which places are the best. Driving towards New York, we would be doing a what selection right here, just using this right. So we're just going towards the direction. We're going which way? So we're starting at the very beginning. We're saying the naive. We got no X's in the model. That's the no X model. We're going to start adding in stuff. So we're going to add in an X. We're going to say, let's put this X in. Let's put this X in. This X is good. This X is good. We're trying to figure out the best stuff right here. We're doing a forward search. Going searching forward. So just think about it again right here. What kind of selection model would we be doing if we, instead of having all the x's, instead of starting with the naive, we start with all the x's in and we remove them? So now we're going to start with the x's in and we remove them. You would call this a what? So now we start with all the x's in the model. Every single one of the x's will be in the model, and we'll start taking them out of the model. So now we're going to start with all the x's in the model and start just removing things. We're doing which way? Which way are we going on our trip? We're going which way on our trip right now? Going backwards. But you might ask me, why can't we do the following? You say, Brian, let's take our trip and let's start driving. And then let's turn around a little bit here. And then let's start driving. And then let's turn, let's go back this way. That's forwards, right? So now let's go backwards. And let's do a search like this right here. Can you do that? Can you go forwards a little bit, backwards a little bit, forwards and backwards, and just keep adding and removing x's? So we start by adding in some x's. We take out some of those x's. We add in more x's. We take out some of those x's. We add in more x's. We take out a little bit more, and then we stop right there. And these are just the x's we're adding in. And Nathan, you're right. We could compare some models. We're not going to do model comparison here, but we're just adding in x's, removing x's. And what would you call this search method? Let's go take a look at it. Let's go take a look at this search method right here. Any ideas what you would call that search method? I don't know if I can show it. Any idea what you... Oh, I can show it. What would you call that search method over there where you go forwards and you go backwards? What do you call that search method? You'd call it a what search procedure? Because you're allowing yourself to put x's in the model or remove them. You can say, well, let's put x's in or let's remove them. At any point, we could just put some x's in. We could remove those x's. What would you call that? I'd call that a what search procedure because it allows for this. You can go forwards. You can go backwards. You can put x's in, forwards. You can remove those x's out, going backwards. So that is called a what search procedure. It's the way you can drive the car. You can drive the car in what direction? If you can put your x's in the model and you can also take them out. Great job, Matthew, right there. Both. So we got the both search procedure. And so the way these search procedures check for the best model is by looking at the AIC. And we're just going to see if putting in a variable or removing a variable will help with the AIC. So once again, all the code is written out for you right here. So make sure to review, and we will be doing an activity on this if you want to see how to do it step by step. But we're going to see the code right here. We need to first create our naive model and create our full model. And you see that right here in the graphic I drew out, is we have a naive model and a full model with all the x's. So the full model has all the x's, tilde dot. The naive model is the code tilde1 to just create an intercept, and that just creates the naive. Now the step procedure takes the following. This is your initial starting position. We are doing a both search with a scope, which takes a list argument, which a list puts in multiple things. So the scope is an argument that takes the list of your models, which we have the lower bound is the naive. That's the smallest model we'll allow it to make. And the upper bound is the full. We generally use those as the boundaries, like a fence saying you can go as low as the naive and you can go as high as the full model. And this is where you're starting. You're starting with the naive. And so the direction will go in both. What direction could we not put here right now that would not do anything? If I put this direction, 500-point question of the day right here, what direction for the code right now would make this model do nothing? Changing this, or it would just not run anything. Boom. Yes. And so great job listening in right there. Understand what this code does. You got it right there, 500 points. Because backwards right now, we're at the naive. So what you'd be saying is we are at the naive. You can go to the full, but I want you to search backwards. So like if you put the direction as backwards, you're currently at the naive. So it would just give you the naive. It would say like, well, if I'm searching backwards, I can't take anything out. I like my theory questions like that. Like, yeah, you can't change that. You can put backwards. You'll just get the naive. It won't do anything. So good stuff right there. If you change, one more quick question. If you change this to the full model to start at, what two search procedures could you do if you had this as full model? And so it would look like you're up here at the full model. what 2 search procedures could you do, like methods of direction could you do from the full model? So if you change that to full as the starting point, which just tells it where's it going to start its search at, so that's where it's starting its search at, then what directions could you search in? Another 100-point question. Both and backwards. Exactly, Matthew. Yeah. Great job seeing it right here, understanding that this is just telling it which way to search from here to look to add or remove X's. So if you say both, you're saying you can remove X's and you can add X's. So it gives you the ability to go backwards. And the backwards right there is also telling it you can just remove X's. It's so cool how this runs. We do have this. I like just showing it because it's just fun to watch, especially if you do some big models. Let's grab the salary data set. It's over to the main screen. It's so quick. So let's go over here, load the salary data, make the naive, make the full, and here we go. 3, 2, 1, let's search for that best model. What? Oh, trace is off. Let's search for that best model. It did it. It went through and tried to optimize. Now, it's not searching through every possible model because this is not all possible, but it went through here, and what did it ask first? It said, should I add in gender, education, months, or experience? Why is it picking gender? Which this is the best variable to explain out of all of these. And why is it the best variable? Is this model biased? Why is this the best variable? And why is it saying, yeah, you should, that variable, put that variable in the model? It lowers the AIC the most. It's saying our AIC is currently at this. If you do nothing, the AIC will stay the same. If you add in gender, the AIC will drop. So now our AIC is at this because we added in gender. So now we look at it and we say, what should we do? And it says, well, don't remove gender because that's going to damage your AIC. Your AIC would go back up. That's a worse choice than just doing nothing at all. The next best choice is to add in months. Like we already have gender in the model. So now we're going to add in months. So now that we have added in months, it says, what should I do now? And it says, add in education because that's going to lower your AIC too. And then it says right here, what should I do now? We say add in experience. And we do this right here, and then we can see we do not want to remove those. So we can make this a little bit more complicated very quickly by going to the raise to the second. And wow, just that quick, really? Should get, yeah, there it is. So here's our best model right here with the interactions. Smaller data set, good computer. The best model right here, and we should compare the AICs. 1087. Ooh, what do you notice about the AICs between those models? Between the 1087 right here for the two-way interaction and the 1088 with the no interactions. Pretty interesting right there. The 1087 with the 1088. What about those? 1087, 1088, the AICs for these models are basically what? So the best AIC from the two-way interaction was 1087. And so that's the best AIC from the two-way interaction model. And the best AIC from the, about the same. So you know what we can do is we could change and do the, now you're going to see some more fun, I think. We can change the way we're doing the search procedure. Still super quick. We just need more data. We see something about finding a model. It takes a while. Just how long? Are there people at jobs that wait 20 minutes? You want to, so what's interesting, especially with 475, you might have stuff you have to run overnight sometimes. It really depends. The goal when finding models, Max, is to write your code in such a way that it gets what you want. That if you write a code that's going to take hours to run, well, one, you can send it off to a like a server. You can buy server time at Y12 or whatever, their supercomputer. So I actually know people who like say like, oh, just send it off to this supercomputer and it'll just crush through the numbers. But also, we were doing some stuff for 475 where people's code was taking 30, 40 hours. And then I adjusted it and I was like, you should change your parameters. And it took like 2 minutes. So sometimes you have a code written that might not be optimized or might have parameters that are causing it to create a really big thing. But we were looking through and yeah, I had people take, that code was taking 30, 40 hours. And then we changed parameters and it took 2-3 minutes. So a lot of times you don't do the all possible search because your return on investment on computing time is really not there. The search procedures are usually like a good way of finding models, but the all possible is going to really, and we could probably run the reg subset on it. Let's go ahead and grab our reg subset code. Those are reg subsets. There's the leaps. So reg subsets, y tilde x comma data equals. And just have the method equals exhaustive. And so let's store it into all. I think it's the, whoops, did one extra thing right there. Oh my gosh, there's the all, and what is the code to view it again? I don't run this one that much. I use other packages, and then we'll stop here in just a second. C models is to view it. C models. And so here's our best model. Oh, well, all B. So the best possible model, and it does violate model hierarchy. So did the search procedure, quick yes or no on this, did the search procedure find the best possible model? 30 seconds on the clock. Did the search procedure find the best possible model? Here's the search procedure. There's the model it found right here. Here's the all possible model. Can we get it both on screen? We can. So here's the all possible model. Here's the search procedure. Did the search procedure find the best possible model? This is how often it goes. And it's in that gray zone, right? Well, the search procedure did not find the best possible model. The search procedure came to this model right here. And that model, I think, is this model here. 1, 2, 3, 4, 5, 6, 7. This might be the model, which is not the best. The all possible found this model. This is the best looking at all possible combinations. So the all possible is saying this is your best. The search procedure came to this model right here. So the search procedure did not find the best, but it's almost virtually identical. Not quite, but it's all right. So that's why they found exactly max 100 points. It found a top 5 model. All models are wrong. Some are useful. Most of these models are pretty identical. This 4-variable model might be worth a consideration. And I promise last question right here. Let me put class over. Why was Brian able to run the all possible on that? And I'd probably run the all possible on that. Why on that one would we run the all possible? Which I'll change it up right here and I won't run the all possible. Why on that one were we running the all possible? Why on that? Let's go here to server 10. Let's go create some models. Why was I able to run the all possible? Yeah, exactly. And you're going to see that right here. And let's predict somebody's height. Impressive stuff. And let's run this. Wait, what? Oh, data. Now watch. This is the search procedure. This is a search procedure. Let's just sit back. Just sit back right here. Just let the search procedure do its thing. It's searching. It'll speed up. It starts going like bloop, 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 bloop. So right now it's probably doing removals. The reason right here. Hey-oh, searching away. We started with the full model, which means we put all the variables in it. So this is every single variable and all two-way combinations, all interactions. So right now it's probably doing a lot of removal because it's probably got a bunch of junk in it. When you think about like, if you put everything into the model, it's doing a bunch of junk. So it's doing a lot of removal. It's computing every single model right now. Like it's looking at all models and all options for removal. So depending on how many variables are in the model, it has to look at what is the AIC with the removal of each one. So you can't really see it. It's real quick right there, but all the AICs are being computed. And it's going towards the naive, most likely. It can go backwards, though. I've got both on, so it could add something back in if later on that thing becomes significant. The trace right here of 1 is letting us see all this beautiful action happen right here. But we got some pretty craziness. We'll let it run for a few minutes more right here. So if this is taking a moment right here, what do you think about this code right here, Wilton? What do you think about that code right there? As we sit here and just like watch our model create. This will work. Better not give me like a crash or something. This is the power of coding. These are the things you could never do by hand. Compute it. You'd be sitting down, you'd be making an AIC for each model, computing the AIC for each model. Yeah, exactly. Like, the problem, and here's the thing, it will die. The reason R will die, do you know the computer reason R will probably not like running line 14? Line 14, you have to do the really big equals true too. Think computer-wise, this probably would crash. If you think computation-wise, why is R probably gonna just explode on that? Some pretty code right there. Why on line 17 now would R explode? Do you think trying to learn a second programming language negatively impacts the ability to learn the first one? I'm planning on learning Python over the break. No, it just can be tougher because your like Python index is at 0, but Max, learn Python. One of my best tips for you right there is to learn Python. I need to get better at Python too. So I highly recommend learning Python. I do love R. R's my favorite. No, got like fights between my languages. See, it is getting quicker. Sometimes it'll like slow down again. It's probably it adds back in some variables or something. Speeding up. You know, if I put it on a song, it's going to take a moment. Oh! I agree right there. 100 points right there. We got our model. And guess what? Summary of S. This model explains 75% of the variation in somebody's height. Man, look at this model. It's a bunch of craziness. You'd have never figured out this model. Of course, gender is significant. Interestingly enough, gender doesn't have that low a p-value. Weight, really significant. Rock, how about those insignificant p-values?
It doesn't matter.
He knows what's up. A lot of interactions on weight. That's really interesting. A lot of weight interactions. A lot of desired weight interactions. I mean, it's what you would expect. GPA interactions. That's interesting, too. But, man, it's a crazy model. Might be overfit. Find out more about that in 474. Well, if you have questions, we'll be doing office hours here soon. I will see everyone in just a little bit. That's some model building right there. Bye for now. 474, more topics on model building.